Adding a new method to a popular interface used to be one of the riskiest things a Java developer could do. I mean, it could literally break tons of existing code in an instant. But then Java 8 came along and fixed it with a really powerful feature called default methods. This was such a big deal, it's what allowed for massive updates to core libraries like the Collections API. Okay, so let's dive into how this one feature lets us evolve our code without fear. This is the million-dollar question, isn't it? It's the classic developer's tightrope walk. You've got to add new functionality, but you absolutely cannot force every single person using your API to go back and rewrite their code. So how do you solve that puzzle? And wow, this really shows the night and day difference. On the left, before Java 8, you add one method and you get what's basically a compilation explosion. All your user's code just breaks. But on the right, with Java 8 and beyond, you add a default method and everything's fine. The existing code just keeps on working. It was a total game changer. To really get why this solution is so brilliant, we first have to understand the pain. Let's take a quick trip back in time and look at exactly why evolving interfaces used to be so incredibly difficult. It all boiled down to one thing. An interface was a strict, unbreakable contract. Every single method was abstract, which meant any class implementing it was chained to that promise. It had to provide a body for every single method. The moment you added a new method, a new link in that chain, snap, the chain broke for every single class that used it. It was this all-or-nothing deal that made changing popular interfaces a huge, huge risk. So how did Java solve this massive problem? Well, they introduced a new hero to the story, the default method. Let's break down what makes it so special. The idea is actually beautifully simple. A default method is just a method that lives inside an interface, but, and this is the crucial part, it already has a body. It comes with a default implementation built right in. This means a class that implements the interface doesn't have to write its own version. It can just inherit the default one and use it right out of the box. And the best part? The syntax is incredibly straightforward. All you do is add that one little default keyword right before the return type. That's the signal to the compiler. So here, getNumber is our classic abstract method. No body, just a semicolon. But getString is a default method. It's got the full implementation, curly braces and all, living right there inside the interface. Pretty neat, huh? Now, look at what this makes possible. Our implementing class, myIfimp, only needs to provide the code for getNumber. The getString method, it gets that automatically, for free. It's just inherited. It doesn't have to write a single line of code for it, but it can still call it and get that default behavior. And that is what makes the new method truly optional for all your existing code. Okay, theory is great, but let's see this in action. We're going to walk through a really practical example with a simple int-stock interface to see how we can evolve it safely without breaking everything. So here's our starting point. A simple int-stack interface with just two methods, push and pop. Now, let's imagine this interface is part of a popular library. Hundreds, maybe even thousands of classes out there in the wild are already implementing it. Now a new feature request comes in. We need a clear method. Before Java 8, we'd be stuck, but now we can just add it as a default method. And check out the implementation here. It throws an unsupported operation exception. This is a super common and really smart pattern. It means all those old classes will still compile perfectly. But if someone tries to call this new method on an old implementation, it'll fail loudly and clearly instead of just silently doing nothing. And here's the payoff. A new, modern class like ArrayIntStack can now choose to @override the clear method and provide a real useful implementation. It effectively opts in to the new functionality while all the older classes are completely unaffected. This is backward compatibility at its absolute finest. This really is the core idea to take away. Interfaces can now grow and evolve. You can add new functionality without breaking that critical contract for all the code that already depends on it. The old code just keeps working. So this is all great, but it does bring up a new question. What happens if a class inherits the same default method from two different places? This is where Java's conflict resolution rules come into play. Thankfully, Java doesn't leave you guessing. It has a very clear three-step rulebook, and it's always applied in this exact order. First, the class itself wins. Second, the most specific interface wins. And if there's still a tie, well, the compiler makes you, the developer, decide. Let's walk through each one. Rule number one is the simplest. A class implementation always wins.
So if your class extends a base class that has a ping method, and it also implements an interface with a default ping method, the one from the base class is what gets used. End of story. No ambiguity.
All right, rule number 2. The most specific interface wins. This comes up when you have interfaces that extend other interfaces. If a child interface overrides a default method from its parent interface, the child's version, the more specific one, is always chosen. Java just picks the one that's closer in the family tree.
But what happens when the first two rules don't apply? Here, our class D implements two totally unrelated interfaces, A and B, and they both have a great method. Now, Java doesn't guess. It gives you a compiler error and forces you to resolve the ambiguity yourself. You must override the method. And notice this special syntax, a.super.greet. This is how you can explicitly choose to call the default implementation from one of your parent interfaces if you want to.
Now that we've seen how they work and how to resolve conflicts, let's wrap up with some key best practices for using default methods effectively in your own code.
The main idea here is to use them for their intended purpose, safely evolving APIs and providing small, optional behaviors. You don't want to treat them as a replacement for abstract classes. Remember, interfaces still can't have instant state, no member variables, so you want to keep your default methods light and focused on a single behavior.
So, as we close out, I'll leave you with something to think about. Go look at your own projects. Is there an interface that's been frozen for years because everyone was just too afraid to touch it? Maybe, just maybe, a default method is exactly what you need to finally help it evolve.